All right, we're back with 2.4, structure of metals and alloys. This is also one we don't have homework over. So if we jump in an earlier video, we talked briefly about metallic bonding. And we said that they form a sea of electrons. So that sea of electrons, basically what happens is all the nuclei kind of go to the center, and then I like to visualize it as like a moat around the nuclei, and those electrons then stay on the outside and are very, very close. So if we look at it as metal bondings be a sea of electrons, the sea of electrons account for such cool properties such as conductivity. Conductivity, remember, is like its ability to conduct heat or electricity, so it moves current, right? All right, then we have malleability. All right, that's our ability to be hammered into sheets. And then we have ductility, and this is our ability to be drawn into wires. So we're talking about drawn into wires. So why do these seas of electrons create that? Since those electrons, first of all, the conductivity, the electrons are all right there next to each other, so it's very easy to pass on charge or temperature, right? The energy of those particles, because they're right next to each other and they don't have to go through the nucleus to pass it on. All right, so our electrons are so close. All right, it's easy to pass on. Now, the hammered into sheets, if our nuclei are all kind of together, we can hammer them into sheets because the electrons are so easy to move. The outsides are just hanging out there, and the electron clouds make up a large, large portion of the substance, and there's not a lot of stuff in it. It's just mainly empty space, so it's easy to kind of spread it out and draw it out. There's one other part here that we need to know for metals, and that is alloys. All right, alloys are a mixture of two or more metal elements. Two or more metal elements. All right, and there are two types of alloys that they ask you to know. In AP Chemistry, we have our interstitial, all right, alloy. This is where we have our small non-metallic atoms in between. We put our in between there. That's interstitial, right? And this makes up, keeps its metallic properties, but it might make it stronger, it might make it heavier, kind of depending on what you want to use it for. Then we have our substitutional alloys, and this is where we just take a metal and substitute, which makes sense, all right? But another metal replaces another. And it might look okay, but there's going to be a little bit different. And the thing with this one, the substitutional, is they have to be the same size. The interstitial should be different sizes of atoms. Okay, but the key that you need to know is you just need to know what these two are. You might be asked to identify a picture, which one is substitutional, which one is interstitial, and so on. All right, see you next time.